So we're going to do the foldable for our exponential functions. We'll worry about cutting stuff out tomorrow. But up at the top where it says exponential function, that is a function that has a variable as the exponent. We also know that it's going to make that J-shaped curve. And so our equation, we've got y equals a, I'm going to put b in parentheses this time, to the x. So the a value is going to be part of your y-intercept. And we'll talk more about that when we get to the back side of this foldable. The b value, that is our multiplier. It's going to be your rate of growth or decay. Just depends, and we'll look into that on each side of this foldable soon. And then this x value right here, that's our input or the time period passed, and we'll see more of that when we get into our story problems. Okay, so let's go ahead and start talking about growth. So for our equation for growth for this whole example, we're going to use y equals 2 to the x. So whenever you have growth, your b value is a whole number. So our b in this case is 2. Our a value, I don't see anything out front because here's our b value in parentheses, so that's why we've got the b is 2. A, there's nothing out front, so that means it's a 1. And then our c, I don't see anything back here, which that's what we'll talk about later. So there's nothing there, so that's a 0. So for our table, I'm going to use -2 to 2. So -2, -1, 0, 1, 2. So you can use Desmos to help you calculate this, and we'll talk about it in our warm-up tomorrow. But anytime I've got an x, I plug that in and I get something out. So 2 to the -2. What that's actually doing is saying 1 over 2 squared, which is 1/4 or a quarter. So same thing here, this is 1 over 2 to the first, which is a half or 0.5. And we will again talk about this during our warm-up, why it's this and not just like -4 and -2, which is a common misunderstanding there. Anything, and I mean anything to the 0th power is always going to be 1. And then 2 to the first is 2, and 2 squared is 4. So again, you can use Desmos and a table to help you find those. So with our table though, we remember it's growth. The y's multiply. Meaning, to get from 1 to 2, I multiply by 2. To get from 2 to 4, I multiply by 2. To get from a half to a whole, multiply by 2. Multiply 2 quarters together, it's 50 cents. So I'm always multiplying by 2. So there's our multiplication. So now we're going to go ahead and graph this. So again, I had -2, -1, 0, 1, 2. This was 0.25. This was 0.5. This was 1, 2, and 4. Our A value, again, was 1. In this case, our B was 2, and our C was 0. Now, check out this y-intercept. See how it's 1 and how our A value is 1. Now, C will help us with the y-intercept as well, but right now the C is 0. So, our y-intercept is 0, 1. So, I'll plot that guy so that we've got that referenced. We'll talk about that asymptote, domain, and range here in a second. Let's plot the rest of these points. -2 1/4, get as close as you can. It's not going to be perfect. -1 1/2, and then we had 0, 1 already. 1, 2, and then we've got 2, 4. So go ahead and plot all those points, and then you should be able to connect them to make that J-shaped curve. Now notice how I'm really, really close to this x-axis, but I'm not going to cross it. That's the asymptote. The asymptote's going to be the line that you're not going to cross. So our asymptote in this case is y equals 0. I'm not going to cross that part. Our domain, we're going to use all real numbers this time. So if you want to write all real numbers, that's fine. This is the fancy way of saying it. And I'm using all real numbers because I should be able to plug in any x, meaning all of these x's will work because it's going to go on. I should be able to plug in any x to our function and it should work. And then again, I should be able to plug in any x and it should work. That's why I've got these arrows here. It means it's going to go on forever and continue to grow. Now the range, we're going to go from the asymptote and then wherever the tail arrow is going to go. So that tail arrow is going up forever. So I know I can go to infinity there. And domain deals with the y, or sorry, range deals with the y. Now, I have this 0 for my asymptote, so you use your asymptote to help you. And you never want to equal your asymptote or infinity. So there's the range. So let's go ahead and talk about decay. For decay, we're going to use y equals 1/2 to the x. So again, let me erase that guy. We are going to put this in parentheses so we don't see anything out front. So our A value is 1 again. Our B value this time is 1/2. And our C value is 0 because we don't have anything back there. So anytime we've got decay, it's going to be a fraction or decimal, which are the same thing, but so I'm going to go through, and again I'll use my -2, -1, 0, 1, and 2. So when I plug those in, so it's a fraction over a fraction, really it'll flip it. So this time I'm actually going to see 4, 2, 1, 1/2, 1/4. Again, I will go over these with you in our warm-up on Friday, but for now you can just plug these equations into Desmos and do the table on Desmos to get out the outputs so we know how to calculate them correctly. So again, for here, from here to here, I'm going to divide by 2. From here to here, divide by 2. From here to here, divide by 2. From here to here, still going to divide by 2. So anytime you have decay, you divide the y's. So let's go ahead and start graphing this guy. Again, remember our A was 1, our B was 1/2, and our C was 0. So we had -2, -1, 0, 1, 2. We had 1/4, 1/2, 1, 2, 4. So again, here's our y-intercept right here. Notice how A and C, they will work together to help us get the y-intercept of 0, 1. So we plot that guy. We're going to plot the rest of our points, so -2, and then up 4, then -1, up 2, and then we've got 1.5, 2 2.25. Drawing our J-shaped curve. So notice now our J is pointing the other way. So they flip over that y-axis for decay. So again, it's going down. That asymptote, again, where is it not going to cross? Right now, it's not crossing the x-axis, so we've got y equals 0. So we look for the horizontal line. Domain, again, it's all reals because I can take on any of these x's and plug it into our equation. Any of these x's, plug it into our equation. So that's why we're going to use this guy. Now the range, same thing. Go from your asymptote to where your tail is pointing. While our asymptote is 0, never want to equal it. Range deals with the y's. And then we're going to point up to infinity. So on the back, what we're going to start working on is actually seeing a c value. So for these examples, I want you to go ahead and try them, but go ahead and make our table starting at 0, 1, 2, 3, and 4. We will deal with the negatives later, so this is what I want you to do for your table for example 1. And your table for example 2, I'll have you start at 0 as well. Use calculators for this, give it your best shot. This is what I want you to work on. I'll check in this and 2 worksheets tomorrow in class. We'll see you then.